In this video, we are going to look at problem solving. And more specifically, we're going to look at how to approach problems in chemistry. We're going to look at our strategy. So the first thing you want to ask yourself out of these, you're going to ask yourself three questions. The first thing is, what do I have? What is it that the problem is giving me? Generally, this is going to be a number in the problem. If you have multiple numbers, the best thing you can do is write out the units of all of your numbers that are given to you, and then see which are conversion factors and which is your given. Generally, your given will only have a number on the top. Of course, there are some exceptions to that, but for the most part, that will remain true. The next thing you want to ask yourself is, what do I want? What is it that I need? So this is going to be a question. It's going to be in the form of a question or what I call a bossy statement. So if your question is, so if your problem is asking you to convert to grams, it might say something along the lines of how many grams are in, that would be grams. The bossy statement would be calculate the number of grams. So make sure that you look at the different forms your need can have. And then finally, you want to ask yourself, how do I get there? What is the pathway? What is the equality that relates my given and my need? So what are the conversion factors? So you're going to find the equalities that relate your given and your need. All right, let's dive right into this with some practice. The height of Mount Rainier is 14,411 feet. Express this quantity in miles. So the first thing I ask myself is, what is my given? Notice that this problem only has one number, so that number has to be my given. So my given is 14,411 feet. This question doesn't have a question mark, so my need is not going to be in the form of a question. It's going to be in the form of a bossy statement. So express this quantity is my bossy statement. In miles, that is going to be my need. So now I can go back and look at the common equalities and find the relationship between feet and miles. There are 5,280 feet in 1 mile. So I can write two conversion factors for that. I can write 5,280 feet in 1 mile, or 1 mile over 5,280 feet. Now let's see how we figure out which one it is that we're going to use. I'm going to start my problem, and I'm always going to start with my given. So I have 14,411 feet. In order to get my units of feet to cancel out, I have to have feet on the bottom. So that tells me I cannot use my first conversion factor because it doesn't have feet on the bottom. And that means I'm going to use the second one I wrote. So we'll write 1 mile over 5,280 feet. Now notice my feet cancel out. The units I'm left with are miles, which is good because I'm trying to solve for miles. So now I can plug this into my calculator. I'll multiply everything across the top and then divide it by everything across the bottom. And when I do that, I get 2.73 miles. So that would be my answer. There are 2.73 miles in 14,411 feet. Or I could say the height of Mount Rainier is 2.73 miles. Let's look at another example. This example also only has one number, so that one number must be my given. My given is 17.3 nanometers. I also notice that there is a question mark in this one, so I need to find my need in the form of a question. So I see how many nanometers. Nanometers are going to be my need. Look at that, I got ahead of myself. 17.3 meters, not nanometers, and my need is nanometers. Meters and nanometers, I can relate them very easily because they are both in the metric system. So I can remember the equality between nanometers and meters. There are 10 to the negative 9 meters in 1 nanometer. So my conversion factor is going to be 10 to the negative 9 meters in 1 nanometer, or 1 nanometer is 10 to the negative 9 meters. I'm going to start with my given. I have 17.3 meters, which means I have to have meters on the bottom, and that tells me I can't use the first conversion factor I wrote. I have to use the second. So we will have 1 nanometer over 10 to the negative 9 meters. So just like I did above, I'm going to multiply everything across the top and divide it by everything across the bottom. And when I do that, I get 1.73 times 10 to the 10 nanometers. These both are examples of one-step conversions. And a one-step conversion is when you only need to use one conversion factor. So I only need to find one equality. Most of the problems that we do are not going to be like this. It's not going to be where you go to your equality list and you see this one equality that relates your given and your need. Most of the time, you're going to have to use multiple conversion factors. So let's look at an example of that. A chemistry professor ran a marathon, which is 26.2 miles. That is the only number I'm given. So that is going to be my given. How many nanometers did he run? So nanometers is going to be my need. One of the first things I notice is that we're going from the US system to the metric system. So I'm not going to find an equality between miles and nanometers. If I look on the internet, I could probably find one. But looking at the common equalities that you'll be given on a quiz or an exam, you'll notice that we have a relationship between miles and kilometers. So that will take us to the metric system. And then from there, we can convert from kilometers to nanometers. So I have that 0.621 miles is equal to 1 kilometer. And then from there, I can convert into within the metric system. Sometimes when you're doing these problems, it can be difficult to really know which conversions you need before you start the problem. So sometimes I just like to start the problem and then figure out where my problem takes me. Just like with the other problems, I'm going to start with my given. And this tells me that I have to have a conversion factor that has miles on the bottom. So if I use my equality between kilometers and miles, that means I'm going to have kilometers on the top and miles on the bottom. Now I'm in kilometers. Notice that my miles cancel out, but the units I'm left with are kilometers and my need is nanometers. So I'm not done with this problem yet. Sometimes it can be hard to convert straight from something like kilometers to nanometers. So I always like to go through the base unit. So there are 10 to the 3 meters in 1 kilometer. Now my kilometers cancel out and I can convert between meters and nanometers. So 1 nanometer is equal to 10 to the negative 9 meters. My meters cancel. I'm left with units of nanometers, which is good because that is what I need. And just like before, I'm going to multiply everything across the top and divide it by everything across the bottom. And when we do that, I get 4.22 times 10 to the 13 nanometers. Nanometers are very, very small. Nanometers are about the size of a bond length. And so that is a very, very small thing. Miles are very long. So it makes sense that there should be a whole lot of nanometers in 26.2 miles. Now, let's say it took them 3.92 hours to run the marathon. What was their speed in miles per hour? When I'm doing this problem, I need to calculate the miles per hour. I will take my miles and divide it by the number of hours it took them to run that marathon. And that will give me their speed in miles per hour. So we have 6.68 miles per hour. The second part of this problem asks me to solve for it in meters per second. Something that people have a really hard time realizing is miles per hour, even though it's written on the top as mph, it really means miles per hour. So again, in order to change miles, which is a US system, into meters, I'm going to have to first convert into the metric system. So I can use the same conversion I did above. We have 1 kilometer over 0.0621. Whoops, too many zeros. There we go. You can see that I have canceled out my miles. And now I have kilometers on the top. Well, I need it to get into meters. So I can do 10 to the 3 meters in 1 kilometer. My kilometers will cancel out. Now I have meters on the top. But notice that I have meters per hour when I need meters per second. So I can convert into seconds. Even though I'm not right next to the hours, I can still put 1 hour on the top right here, and my units will cancel out even if they're not right next to each other. So in 1 hour, I know there are 60 minutes, and I know that there are 60 seconds in 1 minute. So notice my hours cancel out, minutes cancel out, and the units I'm left with are meters per second, which is good because that is what I'm trying to solve for. Again, when I plug this into my calculator, I'm going to plug everything across the top and then divide it by everything across the bottom. And when I do that, I get 2.99 meters per second. Both of these examples are examples of multi-step conversion factors, multi-step conversions. And that's because we can't just use one conversion factor like we did in our previous examples. We have to use multiple conversion factors. These can be a lot more difficult to set up, and they can be a lot more difficult to really figure out the different equalities you're going to have to need. The best thing you can do is just practice, practice, practice. All right, let's look at how we can use percentages as conversion factors. If the thickness of the skin fold at the waistline indicates an 11% body fat, how much fat is in a person with a mass of 86 kilograms? This is a great example of a problem that provides you with two numbers. So I need to figure out which one of these numbers is a given and which one of these numbers is a conversion factor. And I think the best way to do that is write out the numbers with their units. This doesn't really help me because I notice I only have units on the top. So I'm going to break my percentage down. My percentage, 11%, means that I have 11 kilograms of fat per 100 kilograms of body mass. When I rewrite my 11% like that, it makes it much more obvious that the 86 kilograms does not have a number on the bottom, so it can't be a conversion factor, whereas my body percentage, my fat percentage, does. So my given is 86 kilograms. My need is how much fat is in a person with a mass of 86 kilograms. So since it doesn't tell me exactly the units that I need, it just says how much, I'm going to use the units that make sense for this problem. I'm given kilograms, so I'm going to do kilograms of fat. I could easily do grams of fat. I could easily do pounds of fat, but that's going to require more work. And the conversion factor the problem gives me is 11 kilograms of fat per 100 kilograms of body mass. Again, I'm going to start with my given 86 kilograms. What you need to realize is this is body mass. This is the entire mass of the person. So I'm going to write my conversion factor exactly as I have it written here because that gives me kilograms of body mass on the bottom. And now I have 11 kilograms of fat on the top. Notice my kilograms of body mass cancel out, and I'm left with kilograms of fat, which is good because that is what my need is. I can multiply everything across the top and then divide it by everything across the bottom, and that gives me 9.46 kilograms of. I cannot stress to you how much practice these conversion factors require. You have to practice them. You have to practice them on your own and do them over and over again.